Okay, so solving some more exponential and logarithmic equations. Number 19 here is an exponential equation. So in order to solve the exponential equation before we turn it into a logarithm, we have to isolate the exponential term. So let's subtract our 1 first. So 3 times 5 to the 2x is equal to 9. Now, a common mistake here was that some people tried to multiply that 3 times that 5, and you don't get to do that. That 5 has the power of 2x, therefore you cannot multiply the 3 times the 5. You just need to get rid of the 3. The 3 is being multiplied times the quantity 5 to the 2x, so to get rid of it, we're just going to divide by 3. So 5 to the 2x is equal to 9 divided by 3 is 3. And now I can either write that in exponential form or logarithmic form by using base 5, or just simply take my favorite log of both sides. On the left hand side, the 2x gets to come out, so 2x times the log of 5, the natural log of 5. I get to do that, of course, by the power property. It should be equal to the natural log of 3. To get x by itself, we got to divide by everything that is being multiplied times the x. That's the 2 and the natural log of 5. So you can write that as the natural log of 3 divided by 2 natural log of 5. Not everybody did it like that. Some people took, say, the natural log of 3 divided by the natural log of 5, got an answer, and then divided by 2. Or you could take a half of the natural log of 3 divided by the natural log of 5. Whatever, make sure that you're using the proper the number of parentheses here. So whenever you type this into the calculator, it'll open up parentheses on the 3, close it. You need to open the parentheses on the 2, and then whenever it opens it on 5, double close it on the 5. The reason why is because if you don't put parentheses before the 2, it's just going to divide by 2 and then multiply the answer times the natural log of 5. You know, it's something like PEMDAS, order of operations, whatever. So whenever we put this into the calculator, it is approximately equal to 0.341. There we go. Here's our answer on 19. 20, a logarithmic equation. So I can take that logarithmic equation and turn it into an exponential. Okay, so let me point out first of all a common mistake that some people made here. Some people wanted to take this 3 inside here, which is perfectly appropriate by the power property. But just take a look at this. The log base 8 of 2x cubed equals 14. This is the mistake that some people made. It's not just the x that's being cubed, it's this whole entire quantity, 2x. It's that whole thing that you're taking the log of. So I'm going to scratch that. I don't want to do that. I just want to get rid of the 3. It's quicker to get rid of the 3 by just dividing both sides by 3. So the log base 8 of 2x is equal to 14/3. Don't worry that it's a fraction, it doesn't matter. This is an answer to a logarithm. An answer to a logarithm is an exponent. It's an exponent on this base of 8. So 8 to the 14/3 is equal to 2x. Okay, so there's a couple of things we can do here. Let's just go ahead and divide by 2 so that we can get x by itself. Not divide by x. What am I doing? Divide by 2. So x is equal to 8 to the 14/3 power. All of this divided by 2. Okay. So what is this 3 on this bottom of the exponent? That's the cube root. The cube root of 8 is 2. So this is 2 to the 14th divided by 2. And if I have like bases, I can subtract that. That's 2 to the 13th power. And 2 to the 13th power, here, let me do some quick math in my head. That's 8,192, I think. Let's go with it. There we go. That one's done.